Hello everyone. Uh, we will form EBM machining group. We will explain about the EBM machining or electron beam machining. Next, in this group consists of me, Bari Ifat Yusuf Habibie Junior, and Anissa Ul Khairia, and then Michael Fernando Frambun, and the last is Siwi Maulidia Handayani. Next, for the outline, for the first outline is about the working principle, and then second is construction, and the third is working of the machine, and the fourth application of the machine, and the last is the advantage and disadvantage. Next, principle of EBM. EBM is electron beam machining. This machine is process works on basic principle of conversion of kinetic energy of electron into heat energy. When a high-speed electron impinges on a workpiece, they convert its kinetic energy into heat energy. This heat energy used to vaporize material at the contact surface. This process is carried out in vacuum, otherwise the electron will collide with air particle and lose its energy before impinging on work material. Next. For the next slide, we'll explain by Sri Maulidia about construction.
So here I would like to explain and break down about the construction of EBM machining. So the first one is power supply. EBM machining utilizes a voltage in a range of 50 to 200 kilovolt to accelerate the electron from 50% to 80% of the speed light, which is about 200,000 kilometers per second. The second one is electron gun. Electron gun is actually a cathode array which generates the electrons accelerate with a high speed and focus on a required spot on a workpiece. This cathode filament made of a tungsten which is heated at the temperature about 2,500 degrees Celsius, which accelerate the electron emission by the thermionic reaction. The third one is anode. Anode will connected to a positive bias. The electron will pull toward the anode at a very high speed and will produce the cathode filament which not differs from its path. And then the other one is magnetic lenses. The emitted electron are both divergent and convergent. This tool will reduce the divergence of the beam, so only convergent beam to pass to the next stage. Therefore, highly focused beam of electron is obtained. The other one is deflecting coil. This tool does not allow beam to deflect. Thus, forming a high intense of beam will produce in these tools. The last one is workpiece holding device. As the name of the tools, it will help us to handle our workpiece and move it in 3 directions, which is X, Y, and Z axis. Next, please. Okay, so here is the characteristic of EBM. This table shows us the characteristic of EBM machine, such as the accelerating voltage, beam current, electron velocity, power density, and etc. until specific power consumption. Next. Okay, so the third part about working will be explained by Michael.
So next is working. So this working is carried out in vacuum chamber. Start from the first is power supply. When a high voltage supply is applied to the cathode filament, it generates the electrons. These electrons move toward the anode at very high velocity. After passing the anode, the beam of electron is made to pass through the magnetic lens, where diverging and low energy electrons are absorbed, and only converging beam of electron is made to pass through the magnetic lens and deflecting oil. This beam passes through the electron lens and deflecting oil, which focuses the high energy electron beam into the require spot of workpiece surface. The high intense electrons beam hit on the workpiece where kinetic energy of electrons convert into thermal energy and the workpiece material is removed by this intense heat, thereby melting and vaporizing it. Next. So the next one will be explained by Anissa Ulchairia.
For the application of EBM, the first one, EBM is mainly used for micromachining operation on thin materials. The operation include drilling, perforating, loading, and scraping, etc. Second, it is particularly useful for machining of materials of low thermal conductivity and high melting point. Third, for making fine gas orificer in space nuclear reactors and gas turbines bladders. Fourth, flow orificers in wire drawing dies. Fifth, it is particularly suitable for producing very small diameter holes about 0.002 millimeters. Sixth, machining of wire drawing dies having a small cross-sectional area. And the last, it is as alternatives of like optic manufacturing methods in the semiconductor industry. Next, the next is the advantages and disadvantages of EBM. Electron beam machining has the following advantages. The first one is very small holes can be machined in any type of materials to high accuracy. Second, it is a quicker process. Hard and heat-resistant materials can also be machined at a faster rate than conventional machining. Third, it produces good surface finish. Fourth, the physical metallurgical damage to the workpiece is very less. And the last, there is no physical contact between the tool and the workpiece. Therefore, there is no tool wear. The next, electron beam machining has the following disadvantages. The primary limitation are the high capital cost of the equipment and necessary regular maintenance applicable for any equipment using vacuum system. Second, the vacuum requirement limit the size of the workpiece. Third, it can be used for small cuts only and it is only applicable for thin materials. Fourth, the metal removal rate or MRR is low. And the last, at the spot where the electron beam strikes the material, a small amount of recasting and metal splotch can occur on the surface, and it has to be removed afterward by abrasive cleaning. That's all from our group. Thank you.